Hi, I'm Jesse from Circuit Analysis, and today let's talk about sensitivity analyses. So here we have a little circuit, and what we're going to do for a sensitivity analysis is we're going to vary each part in the circuit one at a time, and we're going to keep all the rest of the parts at their nominal value. So to get this simulation going, first we want to come over here and make sure that we're in the SIMETRIX mode. And then we can press the F11 key to get our F11 window going. And we see we have a simulation set up here already, but you want to make sure you have chosen an analysis. So we're just going to do a 1 millisecond transient analysis for now. And now when we run this, we're going to see the output here is this capacitor charging through this network of resistors. So if we want to do a sensitivity analysis on this, we could keep all of these parts nominal, and we could just change the V1 to 11 volts. So say 11 was the worst case maximum value that V1 could be over its life. And then you run this again, and you can see this is the curve for that case, and so the sensitivity would be whatever parameter you're looking at on the green curve over this red curve here of the nominal. So for the sake of this example, let's just measure from 1 volt to 5 volts and see how long it takes, so the rise time for this capacitor charging from 1 to 5 volts. And to start off, what we want to do is make up some tolerances for our part values. So we've put together this spreadsheet here, and this has rows for each part, and then it has columns as we've done in previous videos with just some standard parameters here. So the first one is the reference designator of the part, the second one is the property that we're going to change, and then this is the nominal value, and then beginning of life minimum, maximum, and then end of life minimum, maximum. So what we can do with this is we can copy the whole thing, and we can make a text file in the project directory called tols.txt and paste that in there. And that'll give us something that we can load in with a script and loop through these rows and perform our sensitivity analysis. So we'll save that. Now we can get rid of this and make a new script. And here we can start off, we can just paste the code that we have from our last video where we're doing the multi-step sensitivity, and we can start from here and modify some stuff. So what we had here is we're printing start to the command window, and then we're just saving these characters here, these special characters, tab, open bracket, and close bracket, to use later. And then we're determining the script path here. So this is just the working directory of the project, and we're using that to get the in file, which is called tols.txt now. And then our output file we'll call, just get rid of this multi, just call it senseout.txt. And now we're loading in the contents of the file into an array, and then we're determining the indexes of the headers, the ref prop, and here we have nom and EOL max. But what we're going to want to do is add 3 more here, because we want BOL min, BOL max, and then EOL min and max. So now we're getting our list of reference designators here, and we're initializing our output text to an empty string. And next we're going to set all our values to nominal. So we're looping through our reference designator list, and here, instead of creating this output text file we were doing before, we can get rid of that. And we're on the right track here, getting the values from the columns, and all we need right now is the reference, the property, and the nominal value. So we can get rid of the max. We can copy this nominal. And we can get the property. Now we can save this file, and we'll just call it sense. And actually, there's an easier way that we could get the ref val, because this is just the ref des list I. So now the next thing we want to do is unselect any of the parts that are currently selected, and then select. So we're sending the select statement these three strings, and this one is the option telling it that we're going to use a property, and then this is the property we're going to use as ref, and then this is the value of the property we're going to look for. So we're going to, I guess we're going to need to put brackets around this because we want the value of this. We don't want to send the string ref val. And then if you look over here, just to make it clear what that means, if you look at edit add properties, you can see the ref right here. Property is the reference designator, so R1 in this case. So the next thing we're going to do is a little bit of error checking here. So we're going to skip reference designators that aren't found, and the way we do that is we say if select count equals 0, then we can say echo cannot find component, and we can put here ref val. So select is spelled wrong here, so there, that should be green. And now if we did find the part, then we're going to change the part. So to change the part, you actually change the property, and then the property is going to be what we're passing in here, prop val, which is going to be the value property for all of our cases. And then we're going to give it nom val as the value we're going to change it to. So then we can end if. So now that's it for setting the nominal parts values. We can make some more space down here. I'll just copy and paste the run command. So here we're going to echo do nominal run, and then we'll create our netlist and run. So we call the netlist command. Here's our netlist file name, and then we just run the simulation with that netlist. Now the next thing here is getting the parameter. So let's make a nominal parameter variable, and to get the rise time we're going to get x from y of vout, which is our node name, and we're going to get it at 5 volts minus at 1 volt. So that'll be the time distance from 1 to 5 volts. And the next thing we'll do is output a graph here. So we're going to say plot, creates a new graph, and then give it the name nominal and a y label v out, and then v out here is the node name that it's going to plot. And since we're doing that, that'll replace this probe here, so we can get rid of that. There's a lot of different options for the plot function, so you can go here to the PDF manuals, script reference manual, and here on page 506 you have all these different y labels and x labels and different things you can add when you make a plot. So now that we have our nominal run here, we want to do a run for each sensitivity. So we can create a new loop here. We're going to loop through each part and do a sensitivity run. So we'll use j as our new loop variable instead of I. And we'll loop through the reference designator list again. And now the first thing we're going to want to do inside of this loop is actually set everything to nominal again. So the lazy way to do that would be to just copy and paste from up here. There could be a more efficient way, since most things are already set to nominal at this point, especially the first run, but we aren't terribly worried about efficiency, so we'll just do this. And then we want to do this unselect, select again down here, shift tab to get that in line, and instead of setting the current value at this point, we want to do the current value that we are looping through in this J loop. So that's going to be refDesList, and that's going to be J, the jth entry in the refDesList. And now that we've selected the part, we want to set its value, but we want to check again. So we can copy and paste this to make sure that we found a part. And then down here, before we can set this part, we're going to need to get the reference, the prop val and the nom val for it. So we can copy and paste these guys here, and instead of I, we can just change these to J. Nope. But instead of nom val, here we want max val, so we'll use the EOL max value for the sensitivity. So now let's echo here what we're doing. We're gonna do a run, and let's say which run number we're on. But we could just use I for the run number because we're looping here with I, but that would get weird if we ended up skipping any parts. So we can make a new variable at the top. We can call it let run num equals 0, and then down here we can put let run num equal run num plus 1, so we're incrementing it every time we get into this else. And we can echo do sensitivity run. It'll output the run number. And if we want to be real accurate, we can say of change count, and we can also make a new variable here, call it change count, and we can put it in the very first run up here. If we change a part here, we can say change count. It's change count plus 1. Now we have to put a let here. And that way, for the first run, it will increment this change count with however many it actually changed, which should be the same when we get down here to how many reference designators it found. Oops, and this one here should be up here because it doesn't really matter, but we want that to be the max val. So now we need to run our simulation, so we can take this code we had going up here, just copy and paste that. We're doing a lot of violating of the don't repeat yourself rule, but that's okay. So we're making the netlist, design.net, run that netlist, and then this nom-param we'll call max param now. And this plot here we can call sensitivity, and we'll concatenate run num on there. So we'll have to put some squiggly brackets around this, and maybe the little quotes around this guy. And then instead of doing a plot, we want to add it to our old plot, so we can change this to the curve function. And since it's already got a plot, we don't need to add the y label. Next, we calculate the sensitivity and save it to a file. So we'll let this sensit variable be the sensitivity, and we're gonna we'll just call the sensitivity the max minus the nominal divided by the nominal. And then we'll make this output text, we'll add on to that whatever it had before, and lines j, so that's the current line in the input file in this input file here. So we'll just output a file that looks just like this, but we'll add a column with the sensitivity over here. So then we'll put a tab, and then we'll format the sensitivity to 2 decimal places as a %, and then put a new line at the end. We just need to initialize this output variable, so we can go back to the top and maybe around here somewhere. We'll say that the output text is the first row of the other file, so we have ref tab prop tab /t is the tab once you run it through the escape string, nom, and then here we'll do bol min bol max, and then copy and paste that, get the EOL min, EOL max, and then the last column will be called sensitivity. So we can get rid of this output text here that we initialized earlier. And then next thing we can do down here is we can unselect our part at the end just to make sure nothing's selected, and then we can do next j to close our loop. Oh man, autocorrect. Click outside of there. And then we can paste in here. This will record in our output text our nominal value. So we can say output text is output text and 2 new lines nominal, and then our nom-param. So far output text has the table with the sensitivities, and then it has the nominal parameter. So now that the sensitivity is all done, we're saving the output file here, but another neat thing we can do is save the output graph. And so how we do that is first we want to add a legend to it. So we have this add legend, and we're going to name it by its curve name. And then these here are just some numbers that you can play around with that set the size of the legend box. And then you do copy clip graph file. And here we're going to give it the output file name and .png. And we're saving it as a PNG format. And then we can also save the graph itself here as out file name .sxgph. So this is the actual graph file that you can reload in to view it in the SIMetrix SIMPLIS graph viewer. So that's kind of cool, but to do that we're going to have to change this up here where we're outputting this file name, because we had the .txt in this variable. So we're going to add txt on here, concatenate that on the end of it. And we'll just change this out file name at the top to just be, here it is, sense out. We'll get rid of the .txt, so it's just sense out, and then it will add these extensions down here depending on which file it's outputting. We're ready to test it now, so we can save it and run it. So there it went, ran all the cases. It's a little bit squished over here, it looks like, with the size of this box. So we can come over here and play around with these if we want to. See what that does. So it was just too wide. So if we want to go back here, we can make this 100 instead of 180. And you just have to kind of fiddle around with these numbers until the box looks the way you want it to. Now let's check out the output files. So here's the working directory. And we have sense out. So here's the text file. And it did add the extra column sensitivity, and it has the sensitivity percent differences here. It has the nominal value. So these we can just copy and go back to Excel. We can make a new sheet here, paste those in, and then they're a lot easier to read in Excel. If we go back here, we have these other ones. Here's the saved picture, so you can see it copied it when it was too wide and kind of squashed the graph. And then here's the output graph here, so we can open that in here and see. It opens that back up. So that's great, because now we can see all the parts here, how sensitive they are. So we know that V1 is the most sensitive for our scenario here, followed by R2, R3, and then C1. And you can also see what direction the sensitivities are. So you can see these two here are negative, so that means for the positive ones, if you increase their value, then that's going to make the V out higher. But for the negative ones, if you decrease their value, that's going to make the V out higher. So what we can do with this information is an extreme value analysis. And that's where, to get the extreme value in this scenario, we set these positive ones to their worst case max, and then we set these negative ones to their worst case min. And that will give us the maximum V out, the extreme value analysis, or EVA maximum. So let's automate that in the script too, so we can add a couple more outputs here. So we'll make some more space down here, and we'll go back up to the top here. The first thing I think we're going to want to do is get this stuff here, copy some of that, because we're getting here the lines in from the external text file, but now what we want to do to set the worst case maximum value or minimum value is we want to get the lines from, instead of in file, we want to use the output file. So we'll put here output file, and we'll change this, instead of read file, we're gonna scan the output text and with the tab character delimiting it. We'll call this one lines 2. So this is going to get us the lines from the output text that we've been saving as we go along. And from that we can get the headers just like we did before from line 0. And the index that we want to get from this is the sensitivity index here. And we'll give these a new name so they don't override the old variables. We'll just put a 2 after them. And then this one will become 2 over here. Lines 2. And down here we can do the ref_des list too, so we can copy that from up here. And that one's going to get lines 2. And now we'll write a loop, so we'll set the worst case maximum values, and this will be the BOL, and we'll do just reuse I for I equals 1 to the length of ref_des list 2 minus 1, and we'll unselect, and then we'll select based on ref_des 2. This one actually doesn't need a 2 here because that's new. And then we can get the current sensitivity value from lines 2, the sense index column. And then we can just copy all of this stuff here, because next we're going to make sure that we found the stuff we selected. This one down here is going to be an I. And we don't really need this unselect. We're already unselecting before we select everything. This stuff here we can actually move down here, because we don't want to run the simulation inside of this loop. And this part we can get rid of. This we can get rid of. And what we want is the maximum and the minimum value. So we can copy and paste this guy. And we'll call this one min val, and then we are going to do BOL first. So put BOL min. And these are all for lines I. So we're using I for our loop here. And the next thing we want to do is write an if statement, and we're going to say, we're going to check based on the sensitivity if we should set it to the max or the min. So our sensitivity is cur_sense. And if it's bigger than 0, then we want to do prop max val, because if it's positive we want to set it to the max, because we're trying to get the maximum output. So then we can do else and if. And this one here, we're just going to do the opposite. So if the sensitivity is negative, we're going to set it to its min val, and that's this BOL min val. So here we can echo do run for BOL max, and then this here is going to be doing the run. So design.net, and we're running design.net, and then we can say BOL max param is, and we can get the rise time, and then curve, call this BOL max, and we don't need all of this stuff. And this one's not, I guess this isn't really a param, so we'll call it max out instead. And then we can echo here BOL max and say BOL max out. And then we can also add that to our output file. So 2 new lines, BOL max, and then say BOL max out. And this here, we could have concatenated this on afterwards, but you can also just put it inside these double quotes, and since it has the squiggly brackets, it will still evaluate that as a value. Now this part can just be copied and pasted 3 more times. One thing we can do is put a big comment in here to make the sections easily differentiable, but we can copy all of this, and now we have one section for each of the worst case values. So this is BOL max run. This one here will be BOL min. And if we go through this, we have BOL min and max here already. So we could pretty much just swap this inequality, change this to min, and then BOL min out. And we can copy and paste this. And that's pretty much it. So we can do that for these other 2. So hopefully I got all of those changes. I also noticed there's an error that was going on over here last time we ran the script. It looks like it's this line here, and I think it just has an extra bracket on the end there. So now we can save that, and we can run it and see what happens. BOL max and min and EOL max and min, and we can check out our output files. But it looks like all of these values are exactly the same. So if we go back to the script, also this nominal is at the bottom here, probably should go at the top. So we can find the nominal here. Here it is. We can move that up. Up above the first one of these guys. And then looks like what's going on here is that I forgot to change this guy to an I here. These should all be I's in here. We're not using J's in this loop. Yeah, we got a lot of errors over here too. So we can clear message window. And we can save this and close this. Go ahead and try it again. So it looks like over here it's definitely not setting any parts because it's saying can't find component, so it's always getting caught in this if selection equals 0 statement. So it's also got a whole lot more times it's trying than it should, because there's only 6 or 7 parts and it's got all these times it tried. So to see what it's doing, we can go up here in one of these and just echo this ref des list here that it's trying to select. And then if we run that, we'll get a bunch of stuff here we can look at. So it looks like one thing is that this ref val here should be this ref des list 2i. So we can replace that for all of these. Then it will at least tell us what it's trying to do, and we can get rid of this echo here. Rerun that. Oh, you know what? Here where we're getting lines 2, we're scanning the output text by tab, when we should be doing it by new line. So to get the new line character, we can use escape string with the double slash. So let's save that and we'll clear message window. We'll try running that. So now we're getting this current sense bigger than 0 has no data, so there's something wrong with our current sense variable, so we'll have to add something here to see what that is. So the current sense is v1 and the sense index is 0. So we're getting the wrong column. And sure enough, it's looking for the reference column for the sense index. So this, if we go up here, it's actually supposed to be this column here, sensitivity. So if we save that, now let's try that. So it looks now like our current sense as a percent is showing up as a string and it's not being interpreted as a value. So we could try and cast it as a value, and if that doesn't work, we could just check if the first character is a minus sign or not to figure out if it's positive or negative. Val. Save that, try again. Yeah, so that didn't work, so we can undo that. And we can try down here if current sense here we could say mid current sense, so that'll get a character in the string, and we can say we'll start at 0, so we'll get the first character. We'll do 1 length, so it's going to start at 0 and it's going to go for 1 length and that'll get the first character. We'll see if that is equal to a minus sign, and if it is, then we're going to want to do the min val first, actually, because this is the max. So I want to swap these guys. And then this one will be the max. So we can try that. Hey, so that one might have worked. So now we can do the same thing for the other 3. So we can just copy now. Let's try it. There we go. So now you can see that EOL max and min are the furthest ones out. So the EOL max and min is this beige and blue line, and then we have the BOL max and min are the next ones inside. So at least that makes sense. And now we can get back to our folder here, get our sense output. And now we have the nominal up here, and then we have the BOL max, BOL min, EOL max, and EOL min. And if we open up our picture, we save the picture, and we have our graph here as well. So that's how you write a script to do a sensitivity and a worst case analysis, which doesn't seem to be built into SIMEtrix SIMPLIS. It is a built-in feature in things like OrCAD, Cadence, Spice deal, but there is, if you don't want to do all that, there's this DVM package, which is an extra add-on that's doesn't work for me here, but I believe that they have a system in here where you can do worst case analysis with some tools and sensitivity analysis without writing a script. So that's it for now. Next time we'll go over turning this script into its own function so that we can call it multiple times from a higher level script, and then we can write sort of a test script that goes through multiple sensitivity analyses for different parameters. So see you next time, and thanks for watching.